All right, we're going to move on to inner transactions. Inner transactions are pretty straightforward. They're not too complicated once you get the hang of them. Later on in the tutorial series, we might try more complex kinds of inner transactions or workflows, for example, contract-to-contract calls, or we might also try, for example, launching or deploying a smart contract from our method via an inner transaction. So you basically have a contract that creates a contract. And this is a kind of workflow that's used for like liquidity pools. So you'll have like this master app address or controller address, and it manages several other contracts that represent liquidity pools through global and local states. But for this video, we're just going to submit 3 inner transactions. So one is going to be a singular inner transaction, and then the second and third are going to be grouped. So we're going to learn how to submit a single inner transaction and groups of inner transactions. And they're just going to be asset creations, nothing too crazy. So we're going to get started here by defining our ABI method decorator, as well as the name of the function, which we're going to call inner transaction comprehension. Pass in self, no other arguments. And for now, we're going to return none, but we're going to come back here and add a few things. So for inner transactions, you have to import up here from Algopy. We're going to add it to the list, ITXN. And there are 2 ways to submit an inner transaction. You could just define ITXN and pick one of these. So you can do application call, asset config, asset freeze, asset transfer. And then you could just define it. You can just pick one. Let's pick the asset config. And asset config doubles as creation or configuration. So you could create an asset with asset config, or you can adjust a current asset with asset config. So let's say we're going to define itxn.assetconfig, and we're going to type .submit afterwards. And this is an empty asset config. We didn't define any of these things: the asset ID, the total, unit name, asset name, decimals. But this is just something I really want to quickly show you. So we could submit it like this. It would go through, it would work, assuming the parameters were put into the asset config transaction. But if you wanted to access properties directly through this inner transaction object, what you could do is you could set this to be the value of a variable which we'll call, for example, asset config transaction equals, and then itxn.assetconfig.submit. And what you can see is that the asset config variable now has properties of the asset configuration transaction. So you can get the asset name that you define, clawback address, the asset ID or the created asset ID, and everything else about the transaction, even the transaction ID, I believe, down here. So typically, if you want to access properties directly from the transaction you're creating, you will define it this way. And this is my preferred method as well. So we're going to get started with a test asset creation. And let me just add some space here. So the first thing we're going to need is the total. So we're going to type in total is 1. We haven't created this asset yet, which is why we're skipping config asset. If it was created, we would put in the asset ID. So total is going to be 1. The unit name, we'll input here test number 1. And then for asset name, we'll call it test asset 1. For the decimals, we'll set 0. So this asset can't be fractionalized. It will always either be 1, an interval of 1. Default frozen, we're going to set to false. Manager, we're going to set to the current application's address, which we need to import global for from Algopy. So we're going to say global.currentApplicationAddress, and spelled manager wrong here. 1 second. And for reserve, same thing, global.currentApplicationAddress. And then fee is going to be global.minimum transaction fee. So it'll just grab the minimum fee. And this is the bare minimum, I believe, that you need to create an asset. You could add other things. Let's see here. So you could add Metadata hash, you could add a clawback address, freeze address, rekey, you probably won't ever do, note field if you'd like, but this is what we're going to work with for now. And this is pretty much it for submitting the transaction. And then you can return, let's say we wanted the created asset ID. So let's type in created asset here, dots ID. And we can return this. And this is going to be a uint64. So up here, we would type uint64. And we're going to test this out. So we're going to compile our contract. AlgoKit compile py and transaction comprehension.py as we have it named here. And then we're going to go back to our interact with contract. Oh, there's a new update for AlgoKit. We're going back to, actually we need to launch it first. So we're going to launch. And then we're going to take this app ID that's generated, put it in our .env. And interact with contract. So we already had a few things here. We're going to remove this compose call. We can do this by just adding a hashtag at the front. And we're going to create a new compose call. Pass in our ATC. Add some spacing here. And we named our method inner transaction comprehension. So we'll just copy that and paste that in here. Call ABI method is a string of the name of the method. And we have no arguments, so this is pretty much it. And we could test this now. I'm going to clean this up a little bit while that's running. And our application address does not have enough algo to create an asset. So when you create an asset, you need to allot 0.1 algo of your balance to the asset created. And then for submitting the transaction, we also need the 1,000 microalgo minimum fee. So what we're going to do is, instead of, I know we already learned how to pass in payment transactions from previous videos, but just for speeding things up, we're going to go to bank.testnet.algorand.network and just fund our address here with some testnet algo. And now when we run this, give the algo a chance to get there. Should be good. And we're going to see in the return values, we get the asset ID that was created. And if we go to LoRa, and we paste in this transaction ID, and go to the visual, you see here there's an application call that we submit, and the application that receives that application call creates an inner transaction that creates an asset. And then here in logs, you can see the asset ID base64 encoded. And let's go back here. Oh. And we're going to now submit a group of inner transactions. And what we can do is we can just duplicate this asset config transaction. So we just copy and pasted it twice. And we're going to name this _2 after asset config transaction and _3. Change test number 1 to test number 2 and test number 3. And test asset 1 in the asset name to test asset 2 and test asset 3. And instead of submitting these, we're going to remove the .submit at the end here. And we're going to say submit transaction 1, submit transaction 2 is equal to ITXN.submit transactions. And we're going to pass in our 2 new transactions, inner transactions. And we'll go down here. We can get the created asset ID properties of submit transaction 1 which corresponds to asset config transaction 2, and submit transaction 2, which corresponds to asset config transaction 3. And we can get the created asset IDs by doing the same thing we did previously, created asset.id and created asset.id. And then of course we're adjusting the return statement format. So up here, we gotta create a tuple, indicate that this will be a tuple of 3 uint64s. And now we can compile this. And always make sure to save before you compile. So I'm going to go up here, Control S, or File Save. And then we're going to launch the contract again. Add the new app ID into our .env. And then we're going to try interacting again. But remember, we're going to need some algo. So we're going to take this application address, go to bank.testnet.algorand, paste a new address for the app, dispense. Now it has enough algo to create 3 assets. Run the code for interact with contract. And we see we get back these 3 asset IDs that we just created. And if we go to LoRa, paste in this transaction ID, we see here that it creates 3 asset IDs, and the asset IDs are listed here. And even though we submitted a single transaction and a group of inner transactions, they still appear to be all inner transactions, just differentiated by index, so the order that they occurred. So the submit transactions method here of ITXN, it's more so for you to condense submitting things. And it makes things a little neater if you have several transactions you're submitting. So instead of doing .submit, you can kind of submit all of them at once and kind of get those all together. And also if there are transactions you need to submit simultaneously, you can do it this way. So I know I mentioned I wasn't going to show you guys more complex kinds of inner transactions, but I think since we're here, I might as well go over them. So these are going to be application calls and ABI calls, which are almost the same thing in a way. One just follows an ARC4 standard. So I'm going to call this dev inner transaction 2. Pass in self, return none for now. And we're going to, there are 2 ways to do this. So you can use ITXN, which we've been doing. So ITXN.applicationCall, pass in an app ID, which for now we'll just set to 1 because we're going to need a second application. We're going to need a app args instance. So this is just going to be, I'll just put 1 here, but we're going to get a method signature, which we would need to import ARC4 underscore signature from the ARC4 library. So let's say I created a function and I called it return nothing, takes no arguments, and returns void. So returns nothing. So this ARC4 signature returns the bytes format of the signature. And as I stated earlier in our transaction comprehension, the first argument to an application call will always be the bytes format of the signature of the function or method. So over here in the ARC32 JSON, what it does is it hashes this and converts it into a bytes format. It uses the first 4 bytes, I believe. So over here, what we're doing is we're getting the bytes version or the first app arg for a function called return nothing, which we're going to define in a new contract. And these are just placeholders here, the 1 and 1 here. And then we'll also need an onComplete action. So we're going to import that as well from Algopy. And we'll state here on completion is equal to on complete action. And let's do no op. And what's going on here? Oh, missing comma. No op. And then we'll submit this after inputting the fee, global.minimum transaction fee. And we'll submit this. And then we'll create a ABI call. And this you import from the ARC4 library. So it's going to be ABI underscore call. And we're going to state here results transaction is equal to ABI call. And this is going to be a call to the other contract, a method that creates a local state for this user, and we will return a uint64 after this occurs. So ABI call, and then to indicate the return type for the function, you would input it here. And then we'll create inside here the arguments for the application call. So the first argument is going to be the name of the method. So I have return nothing here. I'll call this local state return something. And the app ID I'll set to 1 for now, but we'll generate another application. For onComplete action, I'll use onCompleteAction.optin because the person who's going to be calling this will be opting in so that they can have a local state set. And we'll also need a fee here, global.minimum transaction fee. And I think we should be good there. We'll create a third one here, another ABI call, but this one returns nothing. So we don't indicate here in open and shut brackets that anything is going to be returned or the type annotation for what's going to be returned. And we don't need result transaction. We only need transaction because there's no results. So it's an empty return, like this one here, the void here. So I'm going to call return nothing again and define the app ID. We'll set it to 1 as a placeholder. On complete action, we're not going to define this at all, but we are going to set the fee to global minimum transaction fee. And then at the end of this function, we'll return the result of the first ABI call or second transaction in these three. So we'll state here, returning a uint64, and this is going to be results, which is accessed here from this second inner transaction. And now what we need is an app ID, and method signature will replace this here, the 1. And let's try compiling this after we get a second application ID. So I'll call this second app, and I'll just start from scratch. It'll be quick. So from Algopy, import ARC4 contract, local state, and transaction. From algopy.arc4, import ABI method, and I'll state here class my second contract, pass in ARC4 contract, def init, pass in self, return none. In this initialization, I can't just pass because I want to set a local state. So I'm going to state here self dots, we'll call it opted in, is equal to a local state instance of a uint64. And we need to pass in uint64 as well. And then we'll create our first method. And we have two methods indicated here. So we have return nothing, and we also have local state return something. So we'll state here return nothing, and this will return none. And then our second one is going to be called local state return something. So we'll create another one here, local state return something. And this returns a UN64, I believe. Yeah, and this is the one where we opt in. So when you have an opt-in feature to the contract, so this means you want the user to have a local state, so they need to opt in when they send this transaction. So for this one here, we'll state allow actions is equal to a list, and in this list, we indicate the strings of what types of actions are allowed. So for this one, I need opt-in. And if it's no opt, you don't have to set it. So over here, since there's no opt-in required, you could just state no opt. But by default, when you don't state allow actions, it understands that it's going to be a no op. So this one will return none. We'll just pass for return nothing. And then for this local state return something, we will set self.optedIn for this sender is equal to UN64.1. And then we'll return UN64.1. And this should be sufficient here. Let me just compile this second application. And I should probably save all and restart this. And it looks fine to me, but you never know. Okay, cool. So let's launch this contract so we can input the app ID here in our transaction comp. We need it here and here and here. So in my launch smart contract, I'm going to change the approval and clear teal file names from transaction comp to my second contract. My second contract.approval.teal and .clear.teal. And let's launch this. And we're going to need a local state spot. So under local schema, num uints, we're going to have one integer for local state. So we can launch now. And in our .env, we're going to define second app ID is equal to, and we should get that app ID shortly. And just in case, I'm going to fund this application address. I'm not sure if it's going to need funding, but let's just give it a try here, just in case. And now we can place in our transaction comprehension contract the new app ID into these here. So I just hit Control D to select all three, and I'm pasting it in here. So with the ABI calls, sometimes it's tricky. So if there is no return statement, sometimes it does want you to indicate that here. I believe they updated AlgoKit, so this should be fine. But let's give it a try and then we'll troubleshoot afterwards. So now we're going to relaunch, well, let's compile our transaction comprehension. Comprehension.py. Perfect. And let's launch it. And replace our app ID here once we get our new one. And let's go to our interact with contract. And we won't need this. App client.compose call. Call ABI method, and it's going to be called inner transaction 2. As a string. And we're going to need to pass in the foreign application, similar to how we passed in a foreign account and a foreign asset. The current application that we're calling, which is a transaction comprehension application, it has no knowledge of other applications, even if it's indicated and hard-coded here in the contract. I still need to pass in this deployed contract into my transaction parameters. Where'd I go? Here. In the foreign application section. So I'll create transaction parameters. There'll be a dictionary and foreign applications. I'll pass in and I'll define it right here. Second app is equal to integer version of the os.getEnv. I believe I called it second app ID. Yeah. And then I can pass this in here. And it has to be a list of app IDs. And if this ever gets a little disorganized, you can always just space it out this way. There, nice and neat. Okay, so let's give this a shot. For our application to submit 300 transactions, it will need 3,000 microalgo at least. So to kind of circumvent, I know we learned how to pass in payment transactions into ABI methods, but just to zoom forward a bit, I'm just going to fund this application as well. Whoops. And we're going to try running this and see how that works. And it looks like it's executing. Cool. And print return values and transaction IDs. So we actually got the return value here from our application calls. So even though, oh yeah, we returned results. So results came over here, and then we passed result, which is the ABI results of the second inner transaction. We passed that result as a return from our entire application call. So let's take a look at this on AlgoKit LoRa. And you'll see our 3 app calls here. And you can format everything that we've done and will do with outer transactions. For example, we define payment transactions with signers sometimes, and we pass them in as arguments. So I had something like payment transaction for fees, and I passed in a transaction here, like my payment transaction. So you could do the same thing in your contract. So if this contract accepted arguments, we can place them here. So let's say I wanted to create payment transaction to second contract is equal to iTransaction, payment, and then sender we don't need to define if it's the application that's sending it. But the receiver, the way you could get this, let's say you wanted to send it to this contract, it wouldn't be best to hard code, because then every time you launch a new second contract, you need to come in here and you need to change these values. What you can do is you can create an application instance from a template. I'm getting too complex here, but just know that you could essentially pass in the payment transaction here. And then in your second app, you would indicate here that under local state return something, you would also want a payment transaction. And then you would pass in G transaction here. And then it would interpret payment transaction the same way as if you call this from interact with contract. But we're going to move on to group transactions. And that'll be the last part of this Comprehension series.